Can continue. Okay, guys, let's move on. Please listen. For reinforcement, we have under reinforcement, we have to calculate for our compression reinforcement, which is K. Then formula is K equals M over B D square FCU. This is the formula. All formulas that we have been using, it's in our BS code. In our BS code. So what's our M for hence BD square FCU? M is our moment. B is our breadth. That is 1,000. Take it as 1,000 millimeter or 1 FCU is characteristic strength of concrete. Eh? What's the question? Check your BS code. You see all the formulas that we are using. You see everything. Just keep searching. You see everything in the BS code. Yes, please know it. No, it will not be given. No. Please know it too. Yes, cram it. So our M for end span is what? 6.79. What's that? What's the question? Yes. This one now for the moment, right? You know we got it from our BS code. That table. No, that table that we checked is always given in the exam. That table. If you check your past question, you will see those tables there. You won't give. They won't give us formula. They won't give us formula. They will just be giving us table. Yes, the table that we need to solve our. What the, which one is that? Oh yeah, let's move on. Then this one, our moments, we will convert to Newton millimeter from kilonewton meter to Newton millimeter. When you convert your kilonewton to Newton is times 1,000 10 to the power 3. Then from meter to millimeter is times 1,002 10 to the power. So total is 10 raised to the power 6. You get. So now we now impute it here. 10 raised to the power 6. We've converted our moment. Our moment here was in 6.7, it was in kilonewton meter. So we are converting it to Newton millimeter. So over our B is 1,000. Just take your B as 1,000. For slab, please, for slab, but not for beam. For slab, take your B. Take B equals 1,000 millimeter. So we have 1,000 times our D is what? Yes. What's the oh, thank you. 124 is in millimeter already. You see, our D is in millimeter. So yeah, this one now is to be in millimeter. Millimeter, yes. That's why we converted our moment to millimeter, Newton millimeter. You get? Yes. So and our FCU in the question is what? FCU 25. Please punch your calculator. Characteristic strength of concrete. For stage. Is there no switch somewhere here? 0.0176, which is 0.0176 is less than 0.15. How is it greater? Is 0.0 is less than 0.156. So therefore, compression reinforcement not required. Not yes, we now start calculating for our tension reinforcement. Then we now recalculate for compression reinforcement again. It doesn't happen in slab. It happens in rectangular solid beam. That's the only place I've seen it so far. Solid beam, yes. Rectangular solid beam. So now we'll move on to our lever arm. lever arm, which is represented with Z. Please, are you writing? Please write to Jubri. That is 0.5 plus root 0.25 minus K over 0.9. Am I correct? Yes. Oh, sorry, there is a D. Yes, sorry. So now we are leaving this in terms of D. We know our effective depth is 124, but we are not going to impute it yet. So our Z equals D into bracket 0.5 plus root. Yes, from where? Our effective depth is 124. We know, right? But we are not imputing it now. We will impute it later. Because there's a condition here too, that if our Z is greater than 0.95D, you will adopt 0.95D. They didn't say 0.95. Yes, later. After this one, we impute it. No, we will not put it now because of that condition that says if our lever arm is greater than 0.95D, you will adopt 0.95D as a lever arm. Do you remember in one way slab? Yep. We can't put it now because, okay, now let's say, okay, if we put it now, we'll get something. But in the condition, it says 0.95D. It didn't say 0.95 times 124. So we want to meet that condition. That condition must be met. That's why we are leaving it as D first. You get. So 0.25 minus K. This is our K. 0.0176 over 0.9. Please punch your calculator. Have you punched it? Okay. 0.98. 98 what? 3. Okay, 98D. 0.98D is greater than 0.95D. So therefore, adopt 0.95D as Z, as our lever arm. Any questions so far? Because it is greater than 0.95D, you adopt your 0.95D. But if it is less, you use your obtained value. Yes, use your obtained value. Any questions so far? Yeah. What's the time? 11:19. And Chika, have you snapped this place? Chika, you are not done. I'll finish it. I'll give you assignments. You go and do it yourself. So that you can practice. You guys didn't submit. You guys not submit. You did not submit. If you like, submit. If you like, don't submit. Just make sure you practice it. But I would prefer you submit in case there's any mistakes so I can correct you guys. Can I move on? No, don't let me clean that. Fash. Where's Fash? Now we are moving to our main reinforcement. That is AS required, which is equals to m over 0.95 fyz. Please listen, guys. All our m. 6.79 power 6 over 0.95. What's our fy in the question? 460. Please check the question. Is it 460 or not? Times, what's our z? Our z? Type d. 0.95. Then we now impute our d as 124. Our effective depth, d, as z. 124. Do we get our? We are solving for our AS required. That is for the main reinforcement required. Yes, that is like area of steel required. You get area of steel, main steel required. Main reinforcement, you see the same. Main steel required. So what is our answer? Please check the question. Confirm for me. Is in the question. FY 460. What's the answer? Please, any other please, another person should punch too. Let's confirm. Oh yeah, one what? 1259.89. No. Please, any another 131. 89 90 Abi. Okay. 90 millimeter squared. So now I want to provide our provision. Please open your reinforcement table. What are you looking for? Open your reinforcement table, please. Everybody. Yes, it's different, please. Reinforcement table, the first one. Please, everybody there. Let me open it here too. Please, is everybody there? Open your reinforcement table, please. No, I want to teach everybody how to use it. I'm coming out. I want to check for my beer. Yes, I.
Ṣé ilé náà ní àwọn
Pépé
tó ní àwọn serviceability app?
ó ní.
A máa lo normal serviceability
Yeah,
formula.
yes, normal.
So
The only difference is that in continuous, you have to calculate for area. You calculate for if it's one-way slab, it must be a one-way slab. The third condition, your QK must not exceed, in the question, you will be given QK, it must not exceed 5 kilonewton. And the last thing is your ratio of QK and GK must not be greater than 1.25, must be less than 1.25.
Must be less,
less than
than
1.25. Yes.
That's all the
Then
condition.
your for moment now is changing. Let's calculate for your force. WLX is your force. Then you now check your table 3.12. You get your moments formula there. For each span you are told to calculate for. You are told to calculate for this, and this.
You now add everything.
No, you know add it. You know it's different moment, different moment, different moments. So you now calculate for reinforcement for each each of these.
You say after you don't
Mo pé tá bá ṣe moment tán, when we are done with moment, we calculate for reinforcement.
yes.
Yes. Now you are calculating for reinforcement for each of these.
So you calculate for
Each, yes. Then you now calculate your serviceability for only M span. Because of exam. In real life, you calculate for everything. So let's move. Are you guys in on the reinforcement table? Yes. No, reinforcement table is different. Yes. No, you take it along with you. You take this one along. You say, oh, it's just a page. No, they will not give us. Check your PQ. They say students are allowed to bring their reinforcement table. So, eh? So let's provide. We want to make provisions. Is everybody there? So now, our bus size, she said, according to her, for your main reinforcements, use 16. According to our lecturer, she said use 16 mm bar size. Yes, for your main reinforcement, AS required. You can use 12 and 10, it's still allowed. You can use 12 for your main reinforcement, then use 10 for your distribution reinforcement. You can, eh? So we are using 16 for our main and 12 for our distribution. You can use 12 and 10, but for beam, don't use 12 and 10, please. Don't use 12 and 10. She said don't use 12 and 10, use 16 for beam, 16 and 12 for beam. But slab, you can use, for slab, you can use 12 and 10 or 16 and 12. But for beam, don't use it. Your beam must be very strong. 16 and 12. Or using something greater, but if you are using something greater than that, it's waste of material, waste of reinforcement. So this one is okay. So now let's provide. Like it to be too thick. No, it's still a waste because of your spacing. Oh yeah, let's provide. To provide, write provide. And in our question, our characteristic strength of reinforcement is 460. So for 460 or 410, it might be 460 or 410. Please check Google. Strength of reinforcement. That is our FY. FC is for concrete. Characteristic strength of concrete. Please, guys, listen. Oh, for 410 or 460, that is our Y. That is high yield steel. High yield steel. But for R is mild steel, which is 250. It's mostly 250, and this one is 410 or 460. So now we will now provide Y, because in our question our characteristic strength of reinforcement is 460. That's why we are using Y. Then you go to your 16, your bar size on this side 16. Then we have 131.90 here. So you add 100 mm square mentally. Don't write it down. That is making 231.90. Then you now go to your reinforcement bar, reinforcement table. Then you go to 16. Then you keep going here. Yes, for your AS required. But for distribution, you use 12. So you now go to, you have 231.90. Then you keep going to that 16 row. Yes, 16 row. The nearest to it, not lesser than the nearest, it must be greater than that, or it must exactly be on 231.90. And the nearest to it is the last bar. Are you getting? Which is 670. The nearest to it, to this not lesser than or so. You get any question? Eh? You can use 12. That is what I said. You can use 12 and 10. She used 16 and 12 in her own example. You can use 12. Even in my own, I use 12 and 10. But she used 16 and 12 example for her own solution. Eh? No, they won't specify. You are the one that will think, like, use the one you want to use for yourself. So let me wipe this. So this is how to provide. That y16. If you are using 12, you write y12. Anybody else can use provide y12. You can use anyone you are using. For this, or should we use y12 and 10? Anyone you want to use, you shall know how to provide for it. Y16 at, we have 670, then you go up to your bar spacing in millimeters. It's under 300. The column is 300 up. This place at 300 millimeter, center to center. Then you now write your 670. We have 670 there. 670 millimeter squared. Then per meter run. Please always add your per meter run from your design load and stuff like that. Per meter run. Or you write it as 670 millimeter square per meter. Please let me use another marker. Yeah. 670. You can use, that's what I said, you can use 12. That is in excess, Abi. You can use 12 and 10. She used 16 and 12 in her question. Anyone, yes, for beam, don't use less than 16 for your mean. She said it, yes. So for our distribution reinforcement, please always add your per meter run. No. Eh? This is the provision, yes. This is the provision AS provided. This is also AS provided. And these are 16 for or you can use 12. 300. If you check your reinforcement table, the column where you are not calculating anything, you just use your reinforcement table. Center to center. Yes, you assume here. I don't want to write this because you don't need to write it. You assume 100 millimeter square. You add it to this. That is 231.90. But don't write it for AS required. AS still required for main reinforcement. You add 100 millimeter square. So let's move on to our distribute. Any questions so far, please? Any question? Yes, for this, you add 100. Okay, let me write it here. Please don't write it in your exam. Oh. Add 100 millimeter squared mentally. Yes. Don't write it down. Just add 100. That will be 231.90. Then you now go to your reinforcement table. The upper one is for slab, while the down one is for beam. So now distribution reinforcement for we are doing for high yield because our FY is 460. So we are doing for high. So the formula will be AS minimum equals 0.13% of BH. If it's that we are giving the question like our FY is 210 or 250 rather, if our FY is 250, we will use 0.24% BH. You get? But now we are using this because our if it's 410 or 460, that is high yield still. we use this for our AS minimum. But if you are given the question that is 250 Newton per millimeter square as our Fy, we will use 0.24% of BH. This one, I mean, like, you know, we have main bar, our main bar, main steel. I'm coming. Let's say we have our concrete cover like this on our slab now. We want to make our slab. We have concrete cover here. Then our main distribution, main steel will go like this. Let's say this is the concrete cover. Our main distribution will go like this. So these points here, this is what I drew out here. I'm looking from side, from front view, yes, front. Yes, it will go like this. Then our distribution steel, which is thinner than this bar size is thinner than main steel. It will go like this. You get. So what's the question that you asked now? Yes, for now for our distribution reinforcement. For this our distribution reinforcement.
You have to move forward the mic.
Low battery.
You have to move the mic. Where far is it?
It's low battery.
That's not come
Eh? Yes, it's along. Yes. If this is the shortest part.
Everybody go and learn yourself. Guys, I want to end this one.